Welcome, everyone, to the October 2022 MIDRC Town Hall, another installment where you can learn more about accessing MIDRC data and MIDRC resources. I am happy to introduce our three speakers. The first one will be Chris Meyer. Chris is a trained evolutionary geneticist, analytical chemist, and automation engineer, and he currently manages the Gen3 user services team at the Center for Translational Data Science at the University of Chicago. And he has been instrumental in MIDRC's evolution. Gen3 is an open source software platform for building data commons and analyzing scientific data that hosts the MIDRC Common, which Chris will demo shortly. After Chris, we have Pierre Chabon. Pierre received his master's from Stanford University, where he's currently working on thoracic imaging research. He's a part of MIDRC's collaborative research project #1, focused on natural language processing of radiology reports for COVID-19. And then we will have Karen Drucker. Karen has been involved in research at the University of Chicago for 20 plus years. Her interests include machine learning applications in the detection, diagnosis, and prognosis of breast cancer, and more recently of COVID-19 patients. She is an investigator on several research groups within MIDRC, including Technology Project 3C, whose work she'll demo today. She's also part of the MIDRC Grand Challenge Working Group, CRP9, and co-lead the MIDRC's Bias and Diversity Working Group, analyzing mitigation strategies for various forms of bias possible in stages of data collection and model development. I now pass the floor to Chris, and we will then go through the other two speakers, and we'll have questions and answers at the end. Thank you. Chris, you are muted.
Thank you, Mary Ellen. Thanks for the introduction, and thank you everyone for joining today. I'm really excited to demonstrate some of the things that our awesome team at U Chicago has been working on in collaboration with ACR and RSNA. We've got a really great team trying to share this amazing data set with the research community. And I'm really, really honored to have the opportunity to show you what we've been working on. So with no further ado, I will share a few introductory slides here and then do a live demonstration. So I'll just go through these slides really quickly. Oh, there we go. So what I'll do briefly is just show you some updates to the MIDRC data portal. Again, the URL is data.midrc.org. And specifically, some of the new things that some of you who were here last time may not have seen, or that's new, are the new test data for COVID-19 test results available in the Data Explorer on the Measurements tab. We've added new harmonized study descriptions and several other filters related to the LOINC playbook. And that was a huge effort by the DQH, the Data Quality and Harmonization Committee, to do that data harmonization based off study modality and study descriptions in the DICOM header information. And then finally, we've got some new study filters that utilize the COVID-19 test data so that users can filter imaging studies based on proximity to either positive or negative COVID tests. Then I'll show how to build a cohort in the Data Explorer, and finally show you how to utilize the Gen3 open APIs to access data programmatically. For example, using a Jupyter notebook or any other type of API request software you'd like to use, like R, Stata, Python, or really any programming language that allows API requests. So going on to the updates to the MIDRC portal. Again, I'll just show some slides very briefly, and then we'll go to a live demo of the portal. But just to point out to those who maybe don't have the portal loaded here, we've got the exploration app up here. So the URL is data.midrc.org/explorer. So it now has a measurements tab, which are the COVID-19 test data. That includes the time anchor of the test, so the days from the index date to the test date are provided. So we don't provide exact dates for PHI reasons, but instead we anchor each patient in time, typically on their enrollment in the study, and then provide the days, negative days would be before a test before they enrolled, and positive would be after. So we provide that difference in days between the index date and the test date. And then researchers can use the raw data if they'd like, using this download button to just download the data and do any sort of manipulations using standard programming tools that they like. Again, the LOINC filters are now in the Imaging Studies tab. So yeah, these are available for download. They include the LOINC long common name, the body part examined, the modality, whether or not there was contrast used, and the LOINC code. And finally, we've integrated, we've derived some data. So for every COVID-19 test that a patient took and we have a record of in the data portal, we've calculated the distance in time and days from that COVID-19 test, each of the COVID-19 tests that the patient took, to each of their imaging studies, so that you can now use a slider, or you can use these minimum maximum boxes, and I'll demonstrate that, to select imaging studies based on their proximity to a positive or negative COVID test. Really quickly here, just some slides to show you the button. Is exploration. When you go to data.midric.org, you can click that button or simply go to the URL for the Explorer. The tabs here at the top represent tables of data. So cases tab would be case data. The measurements tab would be COVID-19 test data. Imaging studies is a table of imaging studies, and imaging series is a table of imaging series. And then you can see on the left, there's this filters area where you can use faceted search to explore the data. And then, of course, I just want to highlight these two buttons. One is for downloading the metadata table, and the other is downloading a file manifest that can be used to access the imaging data for your selection. And then finally, I'll be showing some Jupyter notebooks. We now have a button in the data portal called example analysis. And we hope to continually add Jupyter notebooks developed by the community. We've added a couple now that are in production that you can check out and try out for yourself. Again, we plan to add more and more. We've got about 4, I think, at the moment, maybe 5 in the GitHub repository where you can go to download them. If you go to the example analysis page, you'll see static HTML versions of the notebooks. But if you'd like to actually run them, you can click this link to the GitHub, or I guess you wouldn't click it, but you would just go to the MIDRC organization's GitHub to the tutorial notebooks, which is a public repository. And you can download the notebooks there and try them out for yourself. So that's it for my slides, and I'll just go ahead and pop over here to the actual data portal. Okay, so what you're looking at now is the landing page for the data portal, and you can see you see some charts here that simply show some counts of things. We've got a MIDRC, so you can see we've got about 26,000 cases now. And you can see the breakdown between different projects. And you can see 75,000 imaging studies, and then the counts of different series represented in those studies. This isn't an exhaustive list, but this just highlights some of the modalities that we have the most of, which would be CT series. As you can see, 89,000, 27,000 digital X-rays, 69,000 CR series, and about 3,000 or close to 3,000 magnetic resonance series. So the top navigation bar shows you the different tools available. One of the tools that we recently opened up to the public is this query builder tool. So that's relatively new. And again, the new thing here is also the example analysis page. And there's the data explorer. You can check out our data dictionary there. And workspaces are currently not publicly available, but will probably be soon. We have plans to implement a user pays model where users can access compute resources and charge it to an account. I do want to point out that we have documentation and a quick start guide here. So the quick start guide was developed by some experts at the University of Chicago, and we'll show you some of the basic functionality, how to access data. And I also want to highlight here the email support button, and you can maybe see in the very, very bottom left of my screen here that it's midric-support@datacommons.io. That's our support desk. So if you've ever got any questions, don't send your questions to Mary Ellen. We've actually got a team of 8 experts, Gen 3 experts. If you've got a question about the data portal, how to use it, how to run queries, how to, you've got a question about the data dictionary, anything related to the data portal. If you've got a question or you've got feedback, we'd love to hear your feedback. So please use that support email, and we typically get back to you relatively quickly within the day that you email us. So really the main thing I'd like to show you again is the exploration tool. This has just loaded the cases tab where you can see just some basic charts. These are all configurable. So if you have opinions about what kind of charts you'd like to see there, we can always change these. The filters are also configurable, but you can see here the 2 download buttons. So you can download the table of data. So you can do your own analyses, your own filtering based on just the raw data. You can download it in a variety of formats. And you can also download a file manifest that contains the object IDs of all the imaging studies, all the imaging series, where you can download the images themselves for a cohort of cases that you might select. So just as an example, you could select females who are Black or African American, and you can see as you make selections, it filters down this table of data here, and you can see our selections there are filtered. And then again, you can download this subset of data, and the file manifest also gets filtered. So it went from 180,000 files to only 25,000 there. So again, the new thing here is the measurements tab. So this is the COVID-19 test results, and you can see sort of some summary information about the amount of negative tests and positive tests we have. But this is the raw data, and it's associated with a patient ID and also a timestamp. So again, test days from index, if you see -156, this means the test took place before they enrolled in the study. A positive number here, 15, means they took a test about 2 weeks after they enrolled in the study. And you can use this button here to download that data and filter it any way you like using your own tools, or you can make selections again here. If you want just a positive test, you can do some filtering here using the filters. Some of the other 2 new things here are in the imaging studies tab. So again, you've got a table of data down here. Each row represents an imaging study. This is the study UID. You can see the study modality, and then all the other attached metadata is there in the table, including the IDs of the files associated with these studies. So you can, again, use this button to download the raw data and do your own sort of filtering if you'd like. You can use this button to get a file manifest to download all the images. But you could also use our UI here to make a selection. So the new things here are these 2 sliders and min-max boxes. So for example, this is days from study to positive COVID test. If I'd like, I could do -7 and 7, which would give me all the imaging studies that took place within a week of a positive COVID test. And it filtered it down to about 2,000 studies. And then you can, use these buttons to download. And then we've got the third thing here that we've added that's new are the LOINC properties. So there's a new tab on the filters area called LOINC properties. And you can use the harmonized study descriptions. You can see, unlike, let me clear my selection here. You can see there's roughly 780 some odd study descriptions. These are the raw study descriptions that come out of the metadata, the DICOM metadata embedded in the images. And our DQH team has harmonized those to only about 35 currently that are mapped. And you can see some of them, or quite a few of them, are not mapped yet, but we are working on mapping those as well. So these are using the LOINC playbook again, so that they're harmonized or using a third-party standard. And of course, we've got the LOINC method, which is the modality. And you can see the majority here are X-ray, and we've got CTs. LOINC system, this is the body part examined. So you can select body parts. You can select based on whether there was contrast or not. And then finally, if you know a LOINC code that you're particularly interested in, you can use the LOINC code itself to study or just to filter the data. And then the imaging series tab, again, these are the series level files. So in MIDRC, we've zipped up all the imaging series. So if it's a CT scan, for example, all the instances or the slices in the scan will be zipped up into a zip file. And you can unpackage those and check out the CT scan as you like. And it has some of the same filtering tools. So let's see, how am I doing on time? Got about not much time left here. So I'd like to now shift over to a Jupyter Notebook example. So this is running locally, and you can do the same sort of thing. I'm just running Jupyter Notebook from my terminal, and it launched a browser window where you can see I'm browsing on my computer, and I'm running this querying and accessing MIDRC data local Python Jupyter Notebook. And this is one of the tutorials we have in the data portal right now. I've made a few changes. We will be updating those notebooks with these changes, but just to show you how to do some things. So I've already executed this previously, but just really quickly want to show you import some packages, and you can initialize the Gen3 SDK. You pass it the API and your credentials from MIDRC. And these SDK packages are for authentication and for submitting queries and accessing data tables from MIDRC. So, just to show you that this is running live, I'm just running a little function I wrote to get the project IDs I have access to, and there they are. And it really goes into great detail. I don't really have time to go into all the details and read all of this, but basically you can export entire tables of data from using the API. Here I'm exporting the case table from the OpenA1 project, and you can see it's just a data frame has loaded here with all that data. So these are all 17,000 some odd cases in that particular project. And you can, do whatever you like with the data. This is the raw data. And then, so for example, I can just use Python tools to build a cohort where I say, sex is female, race is Black or African American, and age index is greater than 79. And you can see there's 197 case IDs that match those criteria. You can also use scripts to export all of the data from each project for a particular node, or you can export all of the data from a particular project. So you can see it's downloading the case table, the condition, the CR, CT series, So you have all the tables of data, and there they are. They're in TSV format, which you can load easily using, for example, in Python, you can use pandas to load it as a data frame, which I've done here, and to show all the CT series. There's literally a lot of information here. It shows several different ways to query the data model. Here I'm querying the case table and asking for several properties on the case node, and then I'm asking for the imaging studies, and then finally the X-rays and the object IDs. And you get the response from the API, which looks like this. And it's got some file identifiers in here as well. And I'll just quickly show a few more things here. So the data explorer that I showed earlier runs off of queries as well. So when I check this button and it does the filtering, I could actually, if I'd like, open my developer tools, check one of the buttons, and it actually shows you the queries. But if you look at the payload here, you can see the query and the filters. So you can you can use this built-in query builder, which I've done here, to sort of copy the queries, and then you can manipulate them yourselves. So you can see here, I'm querying imaging studies and getting back the case IDs and some other metadata, including some objects. And I'm using those filters saying like use within roughly a week of a positive COVID test. And it runs and you get the data back. You can send the same sort of query to the API using our SDK, and you can see it here. You can create the queries in a Jupyter notebook, and it sends the data right back. So these notebooks in the tutorial section show you how to do all these things. I give a lot of examples because I'm the type of person that does really well when I have lots of examples that show different ways of doing things. And I showed several different methods. For example, this one, finally, this is the last one I'll show. It's just, I'm asking for imaging studies, and I'd like all of this data back. So the case IDs, the study modality, the race, sex, ethnicity of the case, age, and then the file identifiers, and I can filter, send filters. So this is, again, that week window of a positive COVID test, and I run that, and you can see it's relatively quick. You get a response back, and then you can take those object IDs and use the Gen3 tools. Here, this command is pulling an object based on the identifier of the object, and I'm sending my credentials. You can see the 0 here is a success. So if I take a look now, you can see it downloaded some data. So here's a zip file that contains that. And you can also use the UI to access some of these files. So if I copy a random GUID, I can go to the files endpoint and type in that GUID. And after a moment, it pops up and with a download button. So I can just directly, using our UI, download an image, a series zip file, and you can see there is the collection of images in that particular, what is this, a CT scan. So thanks for watching my demonstrations. I think the next person up is Pierre.
Thank you, Chris. That learned a lot.
Hi, everyone. Well, very happy to be here. I have a couple of slides that should be on your screen right now. So what I wanted to talk about today was how can you share your research projects once you're done with them, your models, the models that you were able to develop, so that for instance, other people at MIDRC or other research teams can access them and build upon them. Let's say, for instance, thanks to the great tool that Chris just presented, you were able to collect a good data set. Then you conducted your experiments. You got a very good model capable of classifying images with or without COVID-19. Maybe you published it. but then you would like to make it like public and easily accessible to other teams. So how can you do that? And a little bit like as examples, I would like to talk also about one or two projects that we did as part of the MIDRC initiative, and that could also like be useful to other research teams. And that's why like we really focused on how to easily share them. So, well, that's a little bit like the two main projects that we did over the past year with MIDRC on our side. First one, which is leveraging radiology reports. So you have like all these radiology reports, of course, the associated radiology images. And based on the text content, you would like to have a model that can say, well, there is like COVID-19 here, or maybe no COVID-19, or maybe you're like uncertain, which can be super useful for follow-up because that can help you, like for instance, like filter the associated images. Because if in the radiology report it says like that is like uncertain for COVID-19, maybe the associated image is interesting to investigate. And also like that can be useful for research projects to have weak labels. So that's like a first model that we developed and that we wanted to make public. And a second one was a de-identifier made especially for radiology reports. So you have like your report full of PHI, maybe like a full data set of such reports. And maybe you would like to make this data set public because like other teams would like to leverage it to build like some nice machine learning models. And so to do that, you need like a good de-identifier capable of having good performance, spotting all these PHI, and with a hide in plain sight approach, being capable of replacing them with a synthetic PHI. This one, so that's also like a project we did, worked super well. We did like most of the tools that were like out there. So we were quite happy and wanted also to make it usable easily by other teams. So I think like part of the strategy to make things public and share them, there is first the models that you developed. So these are like trained instances. You would like to just be able to easily run them on your computer or on the computer of someone else. So that's like a trained model, the model weights, maybe the associated demos. And also like there is the code part, which is more like how you built your model, how you train it. So like that's really like the code source files, so that maybe someone else can build like a new research project on top of what you did. First, for sharing like the model weight, what we did is to rely on a platform which is called Hugging Face. We can have a look here. So, well, the main page, if you connect on platform, would look like it with a personal space. But yeah, access to like lots of public content. Hugging Face is worth mentioning that it's a French startup, which is well super popular, and it's heavily used across like all machine learning fields. And basically, it allows you to access like many models for like a various set of tasks, be it like based on images or text or even audio. You also have like data sets, but this wouldn't be like super useful for us because like biomedical data, you wouldn't really find that here. But yeah, models like that's helpful. And that's a great way to share a trained model that can be, for instance, capable of segmenting images. You can also like find models there. For instance, this one, type that randomly, that's one of our models. And yeah, and have like an organization page. That's the one that we built at our lab, where you can put like all the models that you develop. So that's nice. Like people can easily access your organization page. There will be like all your models here. Everything is free, public, so that's super helpful. And for instance, if we have a look at this one, that's a model. So that's the model associated with the identifier project, which is we just talked about. And so, well, using the Hugging Face platform, the files are just over there, well, including this one, which is really like the file of the model. And so anyone can just log on onto this page and download the model. And associated with that, you also have like the possibility to easily integrate like demos. So that's like for the de-identifier model. So you can just like type a radiology looking text, And you would see like what the model does. So here you can really see that it spots like PHI very accurately, with what you say. So yeah, so that's nice. You can see like the use case. Other research teams could be like therefore convinced that well, this model like that's really like the use case we're looking for. We'd like to download. So yeah, so that's like the Hugging Face tool. That's where like we put like most of our models once we're done with the research projects, and that works super nicely. And also like yeah, so that's a little bit like the demos that you can do there. And also like the good thing about this tool that we found out, it's like it provides like several tools for easily integrating models that you got from other teams into your pipelines, and therefore you can then retrain them and so on. So they did like a bunch of, so that's more like code oriented, but they did like a bunch of libraries allowing you to easily like build new machine learning architecture, or for instance, like easily train on multiple GPUs. So that's super helpful. And just giving like an example of how you can, so either you can like go on the Hugging Face website to fetch the models of our teams, or yourself to share them with our teams. But you can also like rely directly on the scripts. So that's part of the Hugging Face strategy to help integrate models easily. And you can see that, well, even for people that do not code, that looks like quite easy. Well, easy. Well, I don't want to talk for everyone, but so you just like load something, which is like a library from Hugging Face. Then you just specify the tags. So that would be, for instance, text classification using our COVID-19 model. And then you can just like run that on the report, and you would get like a result. So you're happy. And same thing, like for instance, the de-identifier, you just change the task, because that's called like a token classification task. And then you can run your report and similarly get your results. So yeah. And so second part of how we wanted to share our research projects, that was more about the code part. So, well, we managed to share the model weights, but maybe people would like to build upon our code, and therefore would like to easily access our code file. And for that, we used the GitHub platform, which is there. So that's like, in particular, the MIDRC GitHub page. I don't know how familiar everyone is with GitHub, but just shortly, that's a platform that allows you to easily share code. And that also like helps like in project management. So you can just like, for instance, access an organization page, and you would have like here like a bunch of projects. For instance, this one, which is a project for our de-identifier. And so in this project, like you can just like put all your files, all your code files, and give like some instructions on how to leverage this code. So for instance, here what we did is give some instructions on how you can use our de-identifier project to, for instance, do some inference, directly use it, or also like retrain the model on your own reports. And yeah, you can just like put all your instructions there, and that's super easy. And just like stressing the thing that it's more like than just like sharing code, you can use GitHub for project management. So for instance, here you would be able to create some issues and also like discuss with other members of your team. But that's really like when you are coding and developing the project that you will need this part. And so, for instance, like just showing how easy it is to then use GitHub to deploy the code. You could just load like a GitHub repository, which is the name of a GitHub project, I would say. So you can just like load that like easily with a command in your terminal. Then you can like, well, of course, well, go into the folder that you just loaded. You can install dependencies, which is something that is code related. So you just like install like some libraries that are useful to run the code. And then with just a command, so that's in the case of the de-identifier, you can use like the code that you just loaded to de-identify radiology reports. So that's like how it works. And so you have like the Hugging Face part that is like super helpful to share and make public like the model weights, and then the GitHub part, which is also like free and well, allows you to easily like make your code public and usable by our teams. And so, well, I think like just giving an overview, what we did on our side is, well, we do like all the project development part. Maybe we use like the MIDRC tool to first collect the data, then we think about the experiments we run. Well, we're happy because like the experiments were great, and we discovered like some new findings. Then we publish the project, and then we use like both these platforms to share the code, also like deploy easily like some demos so that people are like attracted to our research projects. And then on the side, we use GitHub to share the code, and that works well. Yeah, I'm happy to answer any questions if they are like at the end, I think, of the meeting. Yeah.
Thank you. And Karen.
Yep, thank you, Pierre. I'll start by sharing my screen. Hopefully that'll work out. Okay. So I am going to talk a little bit about something slightly less technical, maybe. The work that we've been doing with the Technology Development Project 3C over the past couple of years. And it's an interactive decision tree type tool to recommend to researchers what metrics might be appropriate for their machine learning tasks. So for tasks that you might encounter in medical image analysis. So I'm showing here the MIDRC homepage because that's actually the easiest way to find our tree, our decision tree. Scroll down. There's our interactive decision tree, and it's a work in progress. So we're watering and fertilizing the tree daily. It's not fully grown yet, but there will be 5 types of tasks that we will recommend metrics for. So classification, detection or localization, segmentation, time to event analysis, that is like survival analysis, and estimation problems. So I will start by walking through a problem that most of you will probably know, which is classification, just so you can see the workings of the tree. And there are 2 types of classification that we identified. It's binary classification, or 2-class, or multi-class classification, so more than 2 classes. So in the case of COVID, it would be classification of COVID-19 positive versus negative versus other types of pneumonia, for example. But let's go to binary classification, which most people are familiar with. And then the first question is about the reference standard, or like we would like to call it, truth. But we all know that there's no such thing as real absolute truth. So the first question is how reliable is your truth? So there's for negligible unreliability and variability, which is what we usually assume what we feel like the case to be, and non-negligible unreliability. This is perhaps the more interesting one because we're not as familiar with this, but I'll start by going to the very reliable truth. So, and then the next question is, what's the type of your machine learning output? Is it binary, like a yes, no, COVID present type output, or is it non-binary, such as a probability of disease? So then we go on to say it's non-binary, have a probability of, say, a patient is COVID positive. And then we have 3 types of evaluation methods that we recommend. First is ROC analysis, precision recall analysis, and perhaps the lesser known predictive operating characteristic curve analysis. And if you are busy working in this tree and you've forgotten abbreviations or definitions, we also have a definitions, terminology, and abbreviations tab here at the bottom. And I'm not going to click on it because I don't want to mess up my screen, but it'll bring up a list of abbreviations and common terminology per branch. So if you click here in classification, you'll get your definitions that are applicable to classification. So here, let's click on ROC analysis that most people are probably familiar with. Most people who work in medical image analysis. So this is an end node. So this is our recommendation node. In this case, we have a paragraph of explanatory text. We even have a video, courtesy of Brandon Gallus. We have references, and we provide also software packages. So here there's in more detail. So we can calculate the area under the RC curve, or plot the entire curve, calculate the partial area, or select a single sensitivity specificity operating point. So if we go here, we see again, more explanation and several RF packages or other freely available packages. We try to recommend freely available software from several platforms so that it's accessible to all researchers. And then again, a bunch of references so that you can do your own research into what methodology might be best for your particular problem. So let's start over. So it's kind of the fastest way. We could go back, but I don't want to scroll too much. So if we go back to here, the interesting question, what do we do if our reference standard is not so great? If we actually, there is an unreliability or variability because, for example, there was a consensus amongst expert readers, but they weren't so expert after all. So then we have a lot of extra information again, and references and appropriate performance metrics that you can use. So I think this is pretty straightforward. There are other branches we're working on is timed event analysis, for example. I'm not going to walk through all these examples, but you can see that there is a analogy between how you navigate through different branches. Like if you go to detection localization, the first question will also be about the endpoint of your task, or then asks about your reference standard again. So you can see there's a whole the levels. They're not identical because sometimes each problem has a different logic to it, but we try to keep very consistent. And then here is again a button with definitions, terminology, and abbreviations relevant to this particular task. Okay, and I think that was about all I wanted to say about our tool. So please come and use it. We think it's pretty thorough, and we recommend software packages, provide literature references, and yeah, thank you very much for your attention.
Thank you. And thank you, Chris, Pierre, and Karen. And now we open up our question and answers. We have had some discussion going on the Q&A that you can click on at the bottom of your Zoom. If there's any question that needs more discussion, you can bring it up now. And also, Emily has been posting information on location of the decision tree, announcement of the COVID Grand Challenge, and other things. So please look at your webinar chat also. So some of the questions that have been appearing on the Q&A tool that we have on Zoom has to do with what can we do in the MIDRC enclave when it gets there. Chris, did you want to maybe verbalize what you've written in the Q&A to see if that sparks further discussion? I think a lot of this will depend on the power of the enclave, and everyone keep in mind that MIDRC is an open data commons, so you can always download data, metadata to your own computer environment also.
Yeah, of course. Yeah, just to clarify about the workspaces. So most of our workspace images are just some basic VMs that have about enough compute and disk storage space to do data exploration. So the main advantage of launching a workspace would be that you could run the tutorials without really changing any of the given paths in the examples, because obviously if you download a Jupyter notebook that has directory paths in it for use in the workspace, you would have to change those paths. And we also have a workspace token service, just a minor point, which is if you're running locally, you have to log in and download your credentials and send those. You authenticate using your credentials, whereas in our workspace, you wouldn't need to do that because we have a service that, when you're logged in, it knows who you are. And yeah, finally, I mean, the workspace images, as anyone who's a researcher and does programming knows, often you have issues with dependencies and installing packages, whereas in our workspaces, we configure those images so that users don't have to install anything special to run the tutorials. So you wouldn't run into any sort of dependency conflicts or any of that mess, which can actually be pretty daunting sometimes when you try to install something that you've never used before. So other than that, it's really just a basic Jupyter environment, or we also have R Studio and Stata Studio, where you can run Stata or R code in addition to the Jupyter Python environments. We are developing a workflow execution service as well. That's in the works to come probably sometime next year. But for running more computationally intensive workflows like image analysis, that using these workspace images, you wouldn't be able to do that because they just don't have enough computational power. They don't have GPUs or anything like that. They're if you're familiar with AWS, they're EC2 instances they're on the small side.
Thank you, Chris. And there is a question on how much storage space are required for downloading this data. Of course, one answer is it depends. Are you downloading one case or 1,000 cases? So it will vary a lot. So that's another thing to think about. It might be better to work in the workspace. However, there have been folks who downloaded. How many, where are we at with gigabytes on the public? It's about 6 terabytes so far, right? Something like that, I think, on the open end.
Yeah, it's close to 6.8.
Oh, 7 terabytes. So that's only if you're going to download everything. But if you are building a cohort, go up there. Is there a tool on the MIDRC where, let's say, someone selects their cohorts by clicking on the type of imaging exam, the demographics, whether or not it's COVID positive or negative? Is there a way for them to get an estimate of this, the gigabytes or terabytes it's going to be for them to download?
We don't have a tool that makes that particularly easy at this point. That is something that users have pointed out that we are working towards, but at the moment, it just gives you an estimate of the number of images, and you can kind of do a back of the envelope calculation, multiply it by however many megabytes, 2 or 5 megabytes, depending on the type of image you're downloading. But yeah, we do intend to provide that tool. Other than that, you can query the file size, and if you could write your own little script that would query the file size and make a sum. But we do intend to make that tool available in the future.
Okay, thank you, Chris. So the capabilities are there for that question. And another one just popped up. Moeji, is the Jupyter Notebook demo that Chris demoed in this presentation publicly available? I believe it's on the GitHub. For Chris? Is the Jupyter Notebook?
Yes, it's in the MIDRC GitHub tutorial notebooks. Here, let me share that. If you go to the example analysis page, there is a link to the GitHub repository where you can download those notebooks. Here, I think. Yeah. I don't know. Can anyone?
You're not sharing right now. Do you want to be sharing?
You put the link in the chat.
Okay.
I was just going to put the link. Yeah.
Okay, that's in the chat. It's in the chat now. That's good. Right. So keep in mind, these questions from all of you are very beneficial. So don't forget that link at data.midric.org that Chris pointed to you. And like he said, don't send them to me, but I just send them to him. So best is to go officially right to him so that you can work on them and constantly improve. It says users, as you start using this, we always MIDRC's always improving. It's a great team. Let's see if there was any other. I think we've answered all the questions. So I think, and we've gone on the links that are in the chat out there. So I'd like to thank again Chris, Pierre, and Karen, and all of you for attending. And this is recorded. So in case your colleagues need to see it, please send them to the link. It will be on the midric.org website. Thank you.